cutter. So as you can see, it's still engaged, but it's beginning to just cut the very far right edge of the gear blank. Now I have set my Y advance to 0 with the cutter oriented against the top of the original gear blank before I hobbed it. Not hobbed it, but cut the preliminary blank teeth. And so that in turn will tell me when I have reached the correct depth, which is about 60 thousandths. So let's go ahead and begin. Hopefully, that's too fast. Let me slow the speed down a little bit. Don't want to begin so aggressively. This is a very gradual process, but one that works really well. Let's make sure that we have engaged. That first engagement is a little bit tricky. Okay, as you can see, the gear is spinning around and being machined automatically. Now we're going to bring the table in this direction just a little bit and gradually work our way across it. Now we advance toward the table, back to the original position, which is about midway, and then advance against the cutter. And continue cutting. A little bit of cutting fluid helps a lot. We can add that to the cutter itself. That tends to smooth things out quite a bit. Okay, now once we have established our cut relatively well, we can increase the speed. And that'll get the job done a little faster. So again, we just keep advancing back and forth as the work is being passed across a cutter. And then we advance toward it again. You can hear it engaging. The idea is to make a pass, wait for the work to be cut one full revolution, and then advance across the cutter about 10 thousandths, let it make another revolution, and so on. Okay, about 3 or 4 minutes of real time have passed, and we are at about 35 thousandths deep on our cut. And again, I'm just applying oil as needed. You can see all the goop being produced, and I just stick it right onto the cutter. Flood lubrication would be wonderful if I had it, but I don't, so I have to make do with what I have. Spray lubricant would also work very well for this. gear, but the worm itself that will be mating with the gear itself out of some hard brass rod, and then we'll be making the worm gear out of aluminum, and that's a pretty good combination of pretty compatible materials there. Should work out quite nicely. And you could imagine if you ever break a tooth on a change gear of your lathe, you can duplicate it easily with a simple hub. And even if the gear costs you $30 to $40 to replace, it will only take you about an evening's worth of work making the hub and cutting out the gear. Okay, I advanced for depth of cut again, and we'll continue to finish this, and when we come back it'll be all finished and cut to the proper depth. Okay, and here you see the gear all cleaned up. Now there's one more thing I need to do when I retransfer this whole headstock and chuck assembly back to the TEG microlathe. There is a little bit of a burr which is created as the tool exits on the rotation side, which I will have to remove by just taking a chamfer cut. Now I want to show you the previous gear that we made and how nicely that meshes. It's practically a perfect mesh. And all done automatically, basically. Okay, I hope you enjoyed this part of the hobbing demonstration. The next thing we will be doing is I'm going to be preparing a blank for the worm gear. Now the computations for worm gear blank are a little bit different, as the cut is a negative cut, or a rather a convex cut into the workpiece.